Hi folks, this is the fourth and the last video segment for assignment number 5. Okay, so it's a word problem. It's a good idea to be able to handle word problems because after all, you're taking this course for a certain reason. You may be in science, you may be in engineering, economics, and you know math, and you're hired usually to solve problems, and therefore nothing is well established as far as here's an equation, go ahead and get the sign of that or the tangent of that. You're given a description of a problem and you're asked to answer some physical problem. Okay, so here's the situation. It says the beam from a lighthouse. Here we have a supposedly a lighthouse, as you can see this. Okay, there's a lighthouse. The beam is making one revolution every 2 minutes. That means the speed of the revolution of the light in there is specified, and based on that, that has something to do with this pi that determines really the speed of that. And so it's given by the what is that? The distance at the time t, the distance d, and I think the distance d is right here. This is the distance, okay, which unfortunately we cannot read it from uh, the thing that came out of the copier. Okay, so this is the d. Okay, this is your 3. So we have a right triangle here. This is 3, and this is d, and this is the angle that it sweeps. Okay, it's given by that expression. First of all, it says what are these values? So let's go ahead and see what we can do here. Okay, so let's go there. What is d at 0.15? Well, you just go and plug it in. So it's going to be 3 tangent of 0.15 pi. Now, this is not the kind of thing that we are supposed to have known. So we have to go to our calculator and get this thing. And then it's asking you about some other d values, 0.25. So this later becomes 0.25 and then 0.45. So I've got to do this thing with my calculator. I've downloaded the TI-84 calculator from their website. The first thing that we need to do, make sure that the angle is set to radian mode. So you click on the mode, okay, and notice that right now it is radian. If it's on degrees, make sure you can change it, and you can scroll down and up by these arrows right there. You see that? Right now it's radian. If I wanted to change it to degrees, I go select this and then enter. But I don't want to do that. I want it to be radian, and that's the only thing that I want to make sure at this point. Okay, so let's see now. We want to type that expression. Now, 3 times tangent of 0.15 pi. I mean, you may have your own ways of doing these things, but let me go ahead and let me clear that. Okay, so I type 3 times, right there, tangent. There is a tangent here. The tangent is, what about, I said right there, tangent of parentheses, okay, 0.15. Let's see now, 0.15 times pi. Now, pi, either you can put 3.1415 in it, or actually it's one of the constants that is used right there. See that? There's a pi there. So it's I suspect that is I can't see that. Is that a pi? Okay, I can make it. We'll find out. So times pi. Now let's try second. That looks like the green looks the green number. So alpha, where's the pi? No, that's not right. This is times r. That was an r. I didn't see it. So let's backspace. Okay. We want pi. So pi must be somewhere here. Pi is used very widely. Is widely used, so it must be somewhere. Oh, it's right there. I think it's this. It's this one. So second there. Oh, there, right there. See that? Pi. And then you can close the parentheses, hit the return, and you're going to get your answer. 1.528. So the answer to this first one is 1. Can't remember what it was. 1.528. Okay, let's go to the other one. The other one is the only difference is that instead of 0.15, it is 0.25. So let's see if we can get this. Can I? I don't think I can repeat it. I may have to type this thing again. So 3 times. There must be an easier way of doing this thing, but okay, so I'm tangent of this was 0.25 times pi. Pi was right there. You see that? But it's this blue color. So second function on the blue, and there's a pi. Hit return, and it's going to become 3. Now, this does not surprise you because tangent 0.25 pi is tangent of pi over 4. Tangent of pi over 4, you should know it's 1. So multiplied by 3, you get the 3. And I think the final one was 0.45. Okay, so let's go ahead and do that. So 3 times tangent of 0.45 times again second function pi was right there, and hit return, and that becomes 18.94. Okay, now let's see what else is asking. So these numbers you can transfer to the answer of these this part A. Sketch the graph of the function for t between 1/2 and 0. Now let's see for a second. Okay, so your variable is between 1/2, less than 1/2, and bigger or equal to 0. Now, let me remind you that if you put a 1/2 here, you're going to have a serious problem. You're going to have infinity, okay? So let's go ahead and do the graphing there. We have to make some adjustment in the window so that we don't get garbage. Let's go there. So I'm going to go to my function. There is my function. Okay, type in. So 3 times tangent, there's the tangent, of pi, there's the pi, second function times pi, times the variable, there's the variable, x, okay, same as time, and close it. Now, if I say graph, you're going to have a serious problem because the function will blow up probably at some locations, the tangent curve. So graph it. You can see it. Oh boy. All right, that's okay. So we're going to change the window size so that it goes between 0 and a little bit less than 1/2. Okay. So window, that's okay. All right, stop there. Okay. As far as x goes, the minimum value is going to be 0. As far as maximum is a little bit smaller than 0.5. So I'll put down 0.49. How about that? Okay. Well, just graph it and see how it looks like now. I think accidentally I put down 49, if I'm not mistaken. Let me go and check it out. The window size, X max. No, 0.49. Oh, this minimum is 0. That's what I wanted. Minimum 0. Next line for max is 0.49. Okay, now graph it. Now graph. Okay, you can see that's shooting to infinity. If I change the window from 0.49 to 0.499, it's going to get worse. Okay, graph, because there's an asymptote at 0.5. You can see that. Yeah. The reason that you don't see much difference is that because the vertical axis, the vertical, uh, this vertical y value is not big enough. So if I make this thing, if I scroll down to this 10 and make it 100, you see that there's a significant difference in the graph because the graph shoots to infinity at 0.49, at 0.45. See that? Yeah, there. Okay, good. So we have basically answered this part, and then it says what happens to the value as d approaches 1/2. Okay, what happens to the distance d as t approaches 1/2? You can see that the value goes to infinity. Okay, we just discovered that. Okay, so let me close this. Come to the last problem. Where's the last problem? Right there. Okay. So it's talking about the shadow of a person. Let's see that. We have a 6-foot tall man. There's a 6-foot tall man. And the sun is rising, so it casts a shadow here according to that formula. There's a little bit of geometry involved here. There's not much physics, just a little bit of geometry. I'm not justifying why that is the case. Actually, uh, let's not worry about it. It's simply this. Uh, if this is the height, okay, from the stuff that we're going to learn about right triangle, you can see that the length of the shadow is going to be simply that whatever you've got here. Okay. Now, find the length of the shadow at 8 a.m., noon, 12 p.m. Okay, so 8 a.m., this T is the time. Let's see now. T is the number of hours since 6 a.m. So when we are talking about 8 a.m., this T is going to be 2. Okay, so let me first go ahead and, for example, in this, the answer to the 8 pen battery low. That's okay. So the answer to the 8 a.m. shadow is going to be 6 absolute value cotangent of pi over 12 times 2, because 8 a.m. is from 6 a.m. is 2 hours. Okay. As a matter of fact, 6 cotangent pi over 6 is something that you should be able to do it without going to the calculator. But let's actually go ahead and do that. So we go here. Where's my calculator? Let me clear all this. So let's go ahead and do that. It was 6 times, oh no, clear everything here. Let's clear everything. Okay, 6 times cotangent, absolute value. Now, absolute value is in math. So let's see now, where is the math thingy here? Uh, let's see. Uh, my older calculator used to have a math list. Let me try the mode here. Normal, so that's fine. That's not what we want. It's not there. So stat. We don't want stat. We don't, but let's try the list. No, oh, there's the math. So let's go scroll down here. There. So what I did is I went to second function list and selected the math menu, and there is the stuff that I'm looking for. Now we have to look for absolute value. So let's scroll down and see whether we can find absolute value. Oh, no, I don't see the absolute value. The only problem, I think these are the stats stuff. Okay, so there must be one for math. Oh, link list. Okay, I don't know where the absolute value here is. You can go to the YouTube and type for GI 384, and it should be. Oh, there's the math right there. Oh God, sorry. Clear. Okay. Oh boy. Scroll down. Absolute value. We should be getting absolute value somewhere. Okay, so it's not over here. Let's check these guys. Okay, I don't see absolute value there. So complex. That might do. Okay, this might do. So let me go ahead. Although this absolute value in complex term means something else, but let's try it. Okay. So we say enter. All right. Okay. So it was cotangent. Now there is no cotangent here. We can do 1 over tangent. 1 over tangent. There's the tangent. And what was the thing that we wanted to type in? Pi over 12 times 2. Okay, pi over 12 times 2. So pi over 12. Yeah, pi over 12. Second function. What is the pi? Pi divided by 12 times 2. Okay, and close the parentheses. Okay, and then we need multiplied by 6, right? 6. Just look at this. 6 times absolute value of cotangent of pi over 12 times 2, except that I couldn't find the cotangent. Well, I know cotangent is 1 over tangent, so that's one way to get around it. So hit return. It's that number. The guy's shadow is 10.392. And similarly, you can do these other ones. The only thing you have to watch out is from at noon, it's going to be t equal to 6, because 6 hours from 6 a.m. to noon. At 2, you have to use 8. And at 5:45, you have to don't use 5.45, okay? From 6 a.m. to 5:45, that's 11 hours and 45 minutes. 11 hours and 45 minutes. 11 hours and 45 minutes. And 45 minutes is 11 plus 45 over 60. So in your calculator, for t, put 11 plus 45 over 60. Okay? Don't use 11.45 because it's wrong. Then you just graph this. Okay? Graph it. Let me graph this thing for you. Let's go ahead and graph it between 0 and 12. Okay, so it's going to be ugly here. So let's go graph on my function right there. Let me clear that. So it's going to be 6 times. Now there was absolute value. Where did I find the absolute value? It was on the math, under complex. I'm surprised that they don't have absolute value in the math section. Right, complex. Where was it? Was it here? Where's the absolute value? Oh, there we are. Number 5. Oops. Okay. Enter. Okay. So it was 1 divided. Oops. Wait a minute. 1 divided divided by tangent, and it was pi over 12 divided by 12 times your variable x. Okay. Hopefully I didn't forget anything. That looks good. Okay, enter. Now let's go graph it. We have to change the window though. Whoops. Syntax. Okay, what did I must have messed up something here in my. Okay, clear this. Okay, so let's go to our function. So 6 times absolute value of 1 divided by tangent. Oh, there's a pi missing there. Okay, so if there's a pi missing here, there's a pi. Oops. There's a pi. Let me hope that I can put it there. So second function, pi, yeah, divided by 12. Okay, times x. I think that'll do it. Close the parentheses. And now graph it. Okay, we just have to change the window. It says x going between 0 and x going between 0 and 1 or 12. Okay, so let's go ahead and do that. Change the window. X going 0 to 12. Now we may have to change these values here, but for now I'm going to say okay, graph it. Yeah. So needless to say that at 2 instances, this guy's shadow becomes infinite. One is when you're way down here, this guy's shadow is extremely big. And the other one is way down there, that the guy's shadow is on the other side and very large. Okay, so at 0, at the dawn and at the sunset. Okay, at the sunset, is it sunset or wait a minute? 0 and 12. So at the dawn when t is 0, and at the sunset when t is 12, after 12 hours, the guy's shadow becomes extremely large, and that's what this graph is predicting. Okay, so that takes care of that. What else is there that is asking? Explain what happens. Yeah, this is what we just we did. All right, have fun.